giving me the opportunity to give the presentation. So I just share my screen. Just tell me if you see my screen. My screen is visible now.
Yes, sir, it is visible. Yes, sir, it is visible.
Okay, thank you. Just give me one moment. Okay, I think it is visible for everyone. So thank you very much to the Lucknow University to inviting me this FDP. I hope every participant have getting the lot of beneficial of this FDP, and it is very useful for your career. So now today we're taking the topic about the designing and simulation software for the PV system designing. My name is Yogesh Kumar Singh, and I'm the Director, Solar Scientist and Solar Expert. I'm a Master Trainer from the National and International Solar Training Program from the National Institute of Solar Energy, Skill Council for Green Job, NAREC, United Kingdom, RANEC, Germany, World Bank Certified Trainer. So before going to the session, just quickly go to my profile. So as per my education background, I am doing my PhD in a solar photovoltaic. I did my MBA in energy and power management, BTech in electronics and communication. I have more than 12-year experience in a research and development field. I give the consultancy services more than 250 megawatt of solar power project across India. I'm the certified master trainer with the Skill Council for Green Job, Government of India, certified trainer with RANEC Germany, NAREC United Kingdom, European Union, and World Bank. I'm also the lead program director and a master trainer of solar system design program of PV system PV Sol at the National Institute of Solar Energy. I also coordinate the various national as well as international training program in India and worldwide. I'm also the green and eco-friendly movement certified trainer. I'm also trained the participant from the Ministry of External Affairs from the Government of India. And I also deliver the invited take guest lecture visiting faculty of university and industry. I'm one of the expert technical team member of International Solar Alliance, and we do the rooftop potential mapping at Ghana on the year of 2019. I also work in a various international projects like that NREL USA, AIST Japan, STEP project, and the Sirius project. And I have also published more than 25 research papers in a different international journal and conferences. So, what are the outcomes come from the session? What are the things you will learn from the today's session? So, the first thing we go to the covering is here. By the end of the session, you should able to identify the basic solar photovoltaic component. Then we will discuss about the types of solar power plant. Then we will discuss about the development of project phase. What are the steps are the required for developing of any project phase? We will also discuss this point. Then we will discuss about the energy yield assessment. What is the energy yield and how can you do this energy yield, and what is the importance of energy yield for the designing of solar power plant and enhancing the solar power plant. Then we will discuss about the different types of parameter which is affected to the PV performance. Then we will discuss about the DPR, because a lot of the time when you go to the designing of the system, so you will also require a DPR. The DPR means the detailed project report, and the DPR is a very frequent document because in a DPR you can getting all the information the relevant to designing and all the things. So we'll also discuss little bit about the DPR. Then we will discuss about the plans cost estimation. What are the major things we will require for the determining the plant cost, and how can we do the determining the plant cost of the solar power plant. Then we will discuss about the PV system designing, sizing tool and simulation. What are the software skills required? Why we need the software? If you do the manual calculation or if you're using the simulation software, so what are the basic difference will become there? So we will also discuss this point. And finally, we will discuss about the need of the software, which is basically industry has utilized nowadays. So we will also discuss this point in the session. Now we come to the first topic. We just talk about the solar. I think a lot of people have know about this thing, the solar and the thing. So basically, solar has worked in a two form. One is the solar thermal, and another is the solar photovoltaic. I think a lot of people have already covered this thing, so I did not go to the basics of this thing, but just I give a brief idea about to you. When we're talking about the solar thermal, we talk about the heat application. The heat application like the drying, cooling, refrigeration, like of that application. So if we require such type of application, we will go to the solar thermal technology. But if we require to the light application like the rooftop, on-grid, off-grid, the battery backup system, the street light and other things, so there we have using to the solar photovoltaic system. Now, before going to the designing, you should understand the sun position. So, before going to the next topic, I just asked the question to the participant. Can anybody tell me how many types of hemisphere? You can write your answer in the chat box, or either you can unmute yourself and tell us how many types of hemisphere. Somebody has told me three. Yeah, next, anyone guess how many types of hemisphere? Yeah, I just want to the keep attention to the participant because there's a lot of people in this room. So I just requested to everyone. So there is a 61 participant in this room. So I just requested to everyone, please give the answer. How many types of hemisphere? Okay, I think there are no responses coming from the participant side. Okay, there is a different. Generally, there is a two type of hemisphere. One is the northern hemisphere, and another is the southern hemisphere. Now, I ask to the participant: India has coming to which hemisphere? Northern hemisphere or the southern hemisphere?
Northern hemisphere.
Southern hemisphere.
Northern hemisphere. Okay. Now, the India has coming to the northern hemisphere, and why I am asking to this thing because sun is rises to the east and sunset in the west direction. But when the country is located to the northern hemisphere, so what will happening here? The sun always moving from east to west toward the south direction. So in India, if you install to the solar power plant in any location, you always putting the module in a south direction. Why? Because in India is coming to the northern hemisphere, and in the northern hemisphere, the sun position, your sun will be traveled from east to west toward the south direction. So this is the first important thing to always remember that whenever you install to the system, you always putting your module in a south direction. Now, if you see this particular view, this is the observer point of view, and suppose that this is a module, or suppose that this is the module. So whatever the 19-degree angle from this particular object, that is denoted to the zenith angle. So this is the zenith angle, this is the 90-degree from that particular object. Now the second angle is the solar altitude angle, and this angle is basically defined to the sun height and the observer position. So whatever the sun height is there and the observer position is there, so it will be denoted to the solar altitude angle. The third important angle is the solar azimuth angle, and this angle is the most important for whenever you design the system and you putting your module in a true south direction. So that's the condition. Your azimuth angle should be lie between 0 to 180 degree. Like that, if you are putting your module in a true south degree, so that's the condition. Your azimuth should be lie between 0 or 180 degree. But if your module has come to the is to south direction, or is to the west to south direction, so that a condition your azimuth angle will be changed. Apart from that, we have the another angle that is called to the tilt angle. So in a solar, basically we are focusing on this particular tilt angle. I just requested to the participant who is not speaking, so please mute your mic so it is better for everyone. Please, I just requested the participant, please unmute yourself. Yeah, now we discuss to the another important angle, and this is an important angle that is called the tilt angle. And this tilt angle is basically defined by the latitude of that particular location. Okay, and whenever we install to the module, you always, I think you already seen the module they have always installed in a tilted condition. So this tilted condition will be deciding the tilt angle of that particular location, and this tilt angle will always depend to the latitude of the location. So if you see the globe, there is the two lines, one is the latitude and another is the longitude. So this tilt angle will be defined by the latitude of that particular location. So yeah, so someone has want to something. Mr. Ravi, Dr. Ravi Akula, you want to say something? Yeah, so please, I just requested to the participant, please mute your mic so it is better for us. Yeah. So now we will discuss about the tilt angle. So that this tilt angle will be the basically different to the latitude of that location. So this latitude will be different to the different type of location. So I just discuss about one case study. Suppose that if you install to the system in a two different location, like that, if one solar system you install in a Delhi and another solar system you install in a Chennai. So in a Delhi, the latitude is the 28 degree, and the Chennai, the latitude is a 13 degree. So what should we can do in that two location? So whenever you install to the module in a Delhi location, you always put up the module in a 28 degree, and whenever you install to the module in a Chennai, you always put up your module in the 13 degree. But you never ever do such kind of thing in a Delhi. You do the 13 degree, and in Chennai the 28 degree. So it will be affected your energy yield. It will be not generate to the optimum amount of energy. So this particular tilt angle is a very much important for the energy generation wise and the other aspects. So you always remember this thing. Now, this tilt angle will also vary to the seasonal wise. So if you see this particular graph, that is called to the optimum array tilt angle. And now in this particular figure, we discussed to the three different conditions, because when our Earth will be rotated, so our sun position will be changed from the summer to winter month. So according to that, our the module orientation will be the tilt angle will be also changed according to the rotating of the Earth direction. So now this particular thing we have discussed the three different situation. The first situation, that is the maximum annual energy generation. The second condition we discuss about the maximum summer energy production, and the third condition we will discuss about the maximum winter energy production. So now, if you see this first figure, so here you can see the three different lines. One is the red, another is the green, and a third one is the blue line. Okay, and this particular line, you can see that your tilt angle is a very close to the latitude, and that's why it will be saying that the maximum annual energy production. So I already told you, if you are putting your module in the proper tilt angle of the latitude angle, so you can generate the maximum amount of energy. But if you're talking about in a second condition, so what will happening in the second condition, that is a call to summer sun path. So initially my sun is the red position, in the green position, but what happened in the summer time, my sun position will be shifted from the green to red, and that particular condition, you can see that my tilt angle will be reduces on that particular location, and my tilt angle will be reduces here. So in a maximum summer energy production, so in the summer month we just reduce the tilt angle. Similarly, when we see the third condition in the winter sun path, so here we can see that my sun position will be shifted from the green line to the blue line. So my sun is now coming in this position, and this particular position, if you see the tilt angle, so this is the very much greater than the latitude angle. And if we are doing this condition, so we will generate it to the maximum winter energy production. Now the question come in your mind, how much angle will be done in the winter and a summer month? So generally there is the thumb rule. The thumb rule is whenever you install to the system, so you just do the latitude plus minus 15 degrees. What is the meaning of this thing? Like that, if you're talking about the Delhi condition, the latitude is a 28 degree. And if I want to install in a summer month, so what can I do? I just do the latitude minus 15 degrees. So in Delhi, the 28 degree, I just do the minus 15 degree. So whatever the angle, like that, the 14 degree or 13 degree, whatever the angle will become, so that particular angle will be decided to the summer month. Generally, the winter month, the same thing. If you adding the latitude plus 15 degrees, so this particular tilt angle will be generated to the winter sun path. So if you're putting your module in this particular condition, so in a winter month, you can generate the higher energy if you are doing to the latitude plus 15 degree. But generally in a solar power plant, we do the fixed tilt kind of condition. So we're just putting our module in a very close to the tilt angle. So this is a very important concept, because sometimes the people have asked to us in a summer month they have a facing the too much problem, they did not getting the enough amount of energy. So if are facing this such kind of things, so they're just using to the tilt angle variation, and with the help of that you can getting the maximum amount of energy production of your system. Now we come to the next topic, and that is the solar resource availability. So I just putting two different word. One is the DNI and another is the GHI. So I just asked to the participant, anyone has anyone idea what is the DNI and what is the GHI? Any have any idea what is the DNI and what is the GHI? Any idea to anyone? Okay, so this is the two different radiation, the resource availability. So one is the DNI, that is called to the direct nominal irradiation. Okay, and the GHI, that is meaning the global horizontal irradiation. So whenever we install to the solar thermal power plant, we always go to the DNI data, like the direct nominal irradiation data. Okay, so if you see this particular map, so you can finding the very few location we have a getting the maximum DNI data. So that's why in India, if you're seeing the India, the solar thermal power plant is very less as compared to the photovoltaic, because in India we are facing to the DNI radiation, the direct nominal irradiation, because we have not enough amount of the DNI data. So that's why in India we did not promote into the solar thermal technology as per the PV kind of thing. Now, if you see the GHI data, that is called to the global horizontal irradiation data. And if you see this particular map and the data, so you can find out in India, the western and the southern part. So like that, Rajasthan, Gujarat, Maharashtra, Andhra Pradesh, Karnataka, Tamil Nadu. So these are the region where the very rich solar resource availability is there. And that's why the maximum solar power plant has installed into this area, because this particular region we have a getting the very good amount of the GHI, that is called the global horizontal radiation. Similarly, the Leh Ladakh and the Kashmir part is also the very good. The GHI data is here, and sometime in the northern state like the Assam and other locations, so it is also very good. The solar potential is there. So if you are putting our module in such type of location, so we are getting to the maximum amount of energy, and we can get the maximum utilization of solar energy. Now, any question from anyone? So you can ask me. Otherwise, we go to the next topic. So you can use your chat box. If any question, you can ask me. Otherwise, you just click the OK. So I will just go ahead. Any question from anyone? Okay. Now we come to the second topic. This is the solar photovoltaic basics, and here we discuss about the different types of module. I think you have already learned in the last 3 days the different type of technology. So that is my thinking. I just asked the question to you. Can anybody tell me how many types of module are utilized in the solar power plant designing? Any idea, any guess? Yeah, different types of modules. I think you all are the faculty members, and this type of response is not uh, thinking from your side. Yeah, different types of module. Any guess, anything. Otherwise, I am in here to explaining to you, but I just want to the interactive session with you. Otherwise, I just deliver the session and then that just go away. So there is a no mean of the learning of any new thing.
Sir, hello?
Yeah, yeah, yeah.
Sir, I believe three, I think, but two I can remember, sir. One is monocrystalline and one is polycrystalline modules.
Okay, thank you. Thank you very much, sir, for your response. Because when the faculty will taught you an online classes, so it is very, very tough.
Another
If
is
you did
also
not give the
amorphous.
response, so we cannot understand कि आप class में होगी नहीं हो. So thank you very much. So basically, there is the two different type of category of the module. One is the crystalline, and another is the thin film. Okay. So you always remember that this is the two different type of technology. One is the crystalline technology, and another is the thin film technology. When we come to the crystalline technology, we have a two different type of segregation. One is the monocrystalline and another is the multi or the polycrystalline. Okay, so this is the both are the crystalline material of the module. So that's why they will call to the monocrystalline and the poly or multicrystalline of the module. Now, the second type of module technology is called to the thin film. And in a thin film, there is a various type of technology like the CDT, cadmium telluride, CIGS, copper indium, gallium diselenide, then amorphous silicon, then the micro mob, the triple tandem. So such type of technology are coming to the thin film technology. Now, but in India, the maximum we have using to the multi or polycrystalline module. So I just explain you why we are using this module in the maximum condition and what is the benefit of the multi or polycrystalline module as compared to the mono or the thin film technology. Now, this particular picture you can see this is the one single cell. So this single cell, so the first we understanding what is the difference between the crystalline and thin film technology. When we're talking about the thin film technology, they all are made by the glass to glass material. And when we're talking about the monocrystalline module, this is a cell. So this is 1, 2, 3, 4, 5, 6. So this is a call to the cell. And when we make the monocrystalline module, so the each cell have getting the edge cutting on the corner. So you can see that this is the type of edge cutting you can find out the monocrystalline module. Why this edge cutting will be coming? Because when we make the ingots, so we just using the Chelosky method, and when we using that particular method, the solar cell in a circular form, and when we the cutting to that solar cell, so it will be come to the corner like that because this is a round shape. So when we are cutting this thing, so it will be given to the edge cutting on the corner of the system. Now, when we're talking about the polycrystalline module, so there is a no such type of edge cutting. This is the normal cell. This is a brick kind of cell. The another difference is when we see the monocrystalline module, you can see that always the cell are the same color, either in the blue or either in a black. Okay. But if you see the polycrystalline module or the multicrystalline module, you can find out the different type of color variation on the module. Like that, your module is a look like blue, black, blue, black, blue, black type of variation. The third type of technology, thin film, we already discussed with you. This is the module are made by the glass to glass material, and this particular module have using the chemical vapor deposition method. So that with the help of that particular method, we have making to the thin film technology. Now in the market, how can you segregate it to this three technology in a three different way? When we're talking about the monocrystalline module, So this module are segregation in a two-way. One is the efficiency and another is the cost. Okay. So when we're talking about the monocrystalline module, so nowadays in the market, the monocrystalline module, the efficiency range around 90 to 21%. The polycrystalline module, the efficiency range around 80 to 20%, and the thin film module, the efficiency range around 15 to 19% nowadays. Now, the second term is the cost. So the module cost will be decided by the per watt capacity. So in our session, I will also discuss about the cost estimation and other things. So that particular way we will discuss about how much the cost will be coming to the module, what is the cost will coming to the inverter side. But when we're selling the module cost will be decided by the per watt capacity. So now the day in the monocrystalline module in the market are coming around 21 to 25 rupees per watt. The multicrystalline module is come around 90 to 23 rupees per watt. The thin film module is come around the 20 to 27 rupees per watt. So this is the three different type of segregation. So now if you are getting the monocrystalline module is at 25 rupees per watt, and if we take in the 100 watt of module, so I just ask one question to you. If my module price is the 25 rupees per watt, and if I want to purchase the 100 watt module, so what is the cost of the module? Can you write the answer in a chat box? If my monocrystalline module is at 25 rupees per watt, and if I want to take the 100 watt module, so what is the cost of one module? What is the cost of one single module? So the cost of the single module is the 2500. Yes, Deepak sir, you are right. So this is around 2500 rupees. So this single module is if this is 100 watts, so the cost is the 2500. But now the day the module is 300, 400 watts. So you just multiply by the 400, multiply by 25. So this particular cost will be coming on the module prices. I think it will be clear for everyone. Any question to anyone? Okay, now we come to the IV characteristic, because it is a very important the scenario, because our module are working to the STC condition. I think the people has already explained you the standard test conditions. So that is called to the STC condition. So in a PV we have a one standard test condition like that. We have the irradiation, we have the temperature, and the third is the air mass. If we have the irradiation is the 1000 watt per meter square, the temperature is the 25 degrees centigrade, and the air mass is the 1.5. So such type of condition is called to the STC condition. So this particular graph is called to the module IV characteristic. Here we can draw the two different lines. One is the voltage, this is come to the x-axis, and another is the current, that is will come to the y-axis. So this particular point is called to the VOC, that is called to the open circuit voltage when the current is 0, and this particular point is called to the ISC, the short circuit current, when the voltage is 0. But now the interesting point is that, but my module is always working to the MPP condition, that is called to the maximum power point condition. So in earlier graph, you can see that your graph is look like this way. But now we just draw the two different lines. One is the horizontal and another is the vertical. So this vertical line is denoted to the VMP. What is the meaning of VMP? The meaning of VMP is the maximum voltage, and the horizontal line is denoted to the IMP. The IMP meaning the maximum current of the system. But now my module are the working in an MPP condition. So if I draw the two different line like the horizontal and vertical, and all the line are matching to the one point, and this particular point is called to the MPP or maximum power point condition. Now in upcoming slide we will learn that how this MPP condition will be vary in terms of radiation and temperature. So we will also discuss this point in upcoming slide. So, so this is the thing. So always remember that your module is always working to the MPP condition. Now, there is a one interesting terminology, this point. So this particular area, you can see that. Can anybody tell me what is the technical name of this area? I think a lot of people has known this thing. This is the MPP condition, but what is the technical name of this particular area? The region under the MPP condition, what is the technical name of this area? No, this is not the answer. This is called to the fill factor. I think a lot of fill factor. Okay, so this fill factor is the important for the defining to the quality of the solar cell and the solar module. Now, how can you define to the fill factor? Can anybody tell me how can you define the fill factor by this graph?
Sir, fill factor is basically the ratio of maximum power to the multiplication of VOC and ISC.
No, multiplication नहीं sir bro, division मतलब division करना होता है. The fill factor is basically
Actually,
defined that.
न्यूमरेटर में मैक्सिमम पावर आएगी और डिनोमिनेटर में VOC और ISC का मल्टीप्लिकेशन आएगा.
जी, yes.
यूं कह सकते हैं
So this is the
theoretical
fill factor is VMP to IMP divided by VOC into ISC. Yes, you are right. So this is the formula of the fill factor. So this is the formula is calling the IMP into VMP divided by VOC into ISC. And now what is the important thing? If your fill factor value come around 0.7 to 0.9 means आपका जो range आ रहा है 0.7 से 0.9 के बीच में आ रहा है, so that's the meaning your module are working in a very efficient way. So if your fill factor value is come down below the 0.7, you never ever purchase to such type of module. Otherwise, this module is not working as the prominent way. So always remember this thing, your fill factor should lie between 0.7 to 0.9, means fill factor is much more value will be higher, so it will be better of the module. But in ideal condition, the fill factor is 100%, like the ideal value is 1. But in a solar, we just consider the fill factor value is lie between 0.7 to 0.9. Now, this is an interesting the concept. So this is a particular graph will be denoted to the effect of the solar radiation. Now I just give the time to the participant for the 1 minute time to the observation of this graph. And if someone has observed this graph, please let me know what you are observing in this graph. So I just give a 1 minute time to you. Yeah, tell me what are the things you are observing here?
Sir, actually it is the IV characteristics of a solar PV cell or module with different irradiations.
Okay.
And as we are increasing the radiation, the short circuit current increases. But there is not much effect on the open circuit voltage.
Okay, so what exactly you are looking here? What are the parameter will be changing here, or what exactly you are looking here? What are the observations are you getting from this particular graph?
Sir, actually in this characteristic, I think temperature is kept constant.
Okay, but there is we are not talking about the temperature. We're just talking about the effect of radiation.
Yes, sir. When the radiation increases, the max peak point is also increases.
Yes, absolutely right. You are getting the right thing. So in this particular graph, if you see that if the radiation is a low, like that initially the 250 watt per meter square, your current value is this much. When the 500, your current is this much. When the 750, your current is this much. When the 1000, your current is this much. So now it is the calling to the effect of solar radiation, like that if your radiation value will be low, means that your current value will be low, but it will be not affected to the voltage parameter. So your voltage will slightly change, but the maximum affected on the current parameter. So that is called to the solar radiation is directly proportional to the current. So if the solar radiation is low, your current value will be low. And once your current value will be low, so you can find out this MPP. So in a 1000, your MPP is this much, then 750, 500, and the 250. So you can also find that your MPP condition will be also decreases on there. So if you did not get into the proper solar radiation, so it will be affected to the total energy generation or the total power of the system. So you always remember that the effect of solar radiation is affecting to the current. Now the similar point is the effect of temperature. So now again I give the 1 minute time to you. Can you observe the point? What are the things you are observing here?
Sir, when temperature increases, the power reduces.
Yeah, when the temperature is increases, your power is reduces. Okay, so you are right. So the initially this is a 0 degree. So my voltage is this much. When the 25 degree, my voltage is this much. When the 50 degree centigrade, my voltage is this much. And when the 75 degree, my voltage is this much. So what is the meaning this thing? When we increase the temperature, my voltage will be drop out. Why my voltage will be drop out? Because silicon has the negative temperature coefficient material. So what is the things of that? If you are increasing the temperature, your resistance will be decreases, and once your resistance will be decreases, your voltage value will be also decreases on that condition. So the lot of the time the people say that in outside is a very hot in the outside. So that's meaning my module has generating the maximum amount of energy. But this is the myth. If your temperature will be increases beyond the 50 degrees centigrade or 75 degrees centigrade, your maximum power is also minimized on that particular condition. So that is the condition is called to the effect of temperature. So the temperature is inversely proportional to the voltage, means that once we increase the temperature, our voltage will be drop out, and once our voltage is drop out, my overall performance or overall power value will be decreases on that particular condition. So now why it will be affected the thing? So this will be called to the effect of the temperature, and this will be defined by the temp. Yeah.
Sir, I have one doubt here.
Sure.
Sir, actually you have said that when the temperature increases, the resistance decreases.
Temperature increases, resistance decreases. Yes.
Sir, which resistance you are talking about? It is series resistance or shunt resistance?
Yeah, I just talking about the shunt resistance.
Okay. But sir,
Yes.
actually in the literature it has been mentioned that the shunt resistance is not affected by the temperature.
No, but if your fill factor will be decreases in this case, so that will be affected in a temperature. You again cross check. Because I think you learn about this formula RT equal to R naught into 1 plus alpha T. That is the formula. R naught is RT equal to R naught into 1 plus alpha T. I think you
Actually,
learn about this thing.
yes, sir, I have learned, but
yeah,
it is valid for the series resistance or shunt resistance. That is the asking.
yeah, I think this is a shunt resistance, because in the shunt resistance that will be affected in the fill factor, because here our fill factor will be reduced and shunt resistance will be affected in the shunt. The fill factor will be affected by the shunt resistance, not in the series resistance. So just cross check one more time. I will also share my email ID or number with you at the end of the session. So we will discuss on the later on. There is no issue. But that is
Okay.
thing. If you increase the temperature, your resistance resistance value will be decreases on that particular case. So that is the thing when we increase the temperature, because this is the negative temperature coefficient material or the temperature so that's why it will be given to the negative effect is here. So if you
Sir,
see this particular graph, yeah.
Sir, actually in the data sheet,
Yeah.
there are certain temperature coefficients are mentioned, but these temperature coefficients are with respect to the voltage, current, and power, not with respect to the resistance.
Yes.
So,
Yes.
how can we determine the temperature coefficient of resistance, sir?
Yeah, that is the RT equal to R naught into 1 plus alpha T. That is a simple formula. So with the help of that, you can define that You can given the particular temperature, and then you can define the alpha. Alpha is the temperature coefficient. But in the particular thing, I just come to that point. If you see the IV curve, so the IV curve is a three important parameter. One is the voltage, another is the current, and third in the power. Okay. So if you see this particular thing, so in every data set, there's a three value: the temperature coefficient for the voltage, temperature coefficient for the current, and the temperature coefficient of the power. Okay, so there are three different type of value. Now, when we discuss about the first thing, because the silicon is the negative temperature coefficient, and if you increasing the temperature like that, if I increasing the 1 degree centigrade of the temperature is here, my voltage value will be reduced around minus 2.3 millivolt. So that will be reduction will be happening in a VOC. This is the normal silicon material we have taking. So if you're increasing to the 0 degree centigrade of temperatures, to that particular condition, your voltage value will be changed around minus 2.3 millivolt of that condition. Similarly, if you're increasing the 1 degree centigrade of the temperature, so my current value will be increases around plus 6 microampere. So this is the millivolt and this is the microampere. So if you multiply by this milli and micro, so overall you can find out, because the power formula is the voltage into current. So if you multiply by the voltage into current, so the overall you can finding the your power value will be reduced on that particular case. So that's why they have a return to the temperature coefficient. So the temperature coefficient is voltage is always negative. The temperature coefficient of the current is always positive, and the temperature coefficient of the power is always negative in all the cases. Okay. I think it is a clear, sir.
Yes, sir.
Okay. Any other question from anyone? Okay. Now we come to the next point, that is a call to the Indian power sector. Now, can anybody tell me what is the total installed capacity in India now the time?
It is around 390 gigawatt.
390 gigawatt. Okay, you are right. So at the figure of 31st March 2021, we have already achieved around 382 gigawatt. So definitely in the 2 to 3 months, that will be additional. So it will become around 389 or 390 gigawatt of the capacity. Now, if you see this particular power sector at a glance, so in India, the coal will be produces around 53%. The renewable energy is the 25%, the hydro is the 12%, nuclear is the 2%, the diesel is 0.18%, the gases is the 6%, and the lignite is the 2% of the system. So still we have getting the maximum amount of energy demand will be fulfilling by the coal side. Sorry. Similarly, if you see the renewable energy kind of thing, so in India, the maximum the RE potential will be come from the solar power and the wind power source. So in India, the around 42% of the solar power installation and a 42% of the wind power installation is happening in India, and we have a getting around 5% of the small hydro and 11% of the biopower of the energy. So this is the power sector at a glance. So with the help of that, we can see that the lot of the development will be coming on this sector. Now, why I am giving this slide to you, because I just give to the potential of renewable energy in India. So now currently we have a generating around 382 or 390 gigawatt. But if we only depend to the renewable energy, so we can generate more than 1,000 gigawatt of the energy with the help of renewable energy potential. And here, if you see this particular slide, so in a solar energy potential in India, around more than 750 gigawatt. The wind energy potential is more than 300 gigawatt. And if you see the bioenergy potential, so it will become around the 25 gigawatt, or the small hydro, it will become around the 15 gigawatt of potential. So if you are adding to all of the gigawatt, so the potential will be coming in a more than 1,000 gigawatt of the system. Now, this is the exponential growth of renewable energy in India. So in x-axis, you can see the different type of years like the 2002, 2007, 2012, 2018, and 2022. What is our target? So in the y-axis, you can see the renewable energy capacity, and in x-axis, you can find out the different year, and as well as you can find out to the different energy sources like the wind, the small hydro, biomass, and the solar energy. Now, in this particular graph, you can see that in a 2002, the total installed capacity in India is around 3.5 gigawatt. Now, after the Jawaharlal Nehru National Solar Mission has come in a 2010, in a 2012, we have a getting to the tremendous growth on this field, and we can achieving around 24.9 gigawatt in a 2012. And in upcoming the next 6 years, we will getting around 71.52 gigawatt of the installed capacity in a 2018, and the 175 gigawatt we have the targeting around 2022. So that particular potential we have achieving in a 2022, and more than 90 gigawatt we have already achieved it, and a lot of tender in upcoming day will be coming in the solar field, and definitely we can achieve this target in the 2022. Now, this is the roadmap for the system. So we have decided the 100 gigawatt for the solar, the 60 gigawatt for the wind energy, the 5 gigawatt for the small hydro, and the 10 gigawatt for the biomass energy. But now we are basically focusing in a solar field. So now we just discuss about the potential of solar energy and how much the energy segregation we can done with the help of solar energy. So in this 100 gigawatt of solar energy allocation is already defined that the 20 gigawatt for given to the solar park, the 10 gigawatt will be given by the unemployed, the youth and farmers, the 30 gigawatt for the government, state and private authority, and the 40 gigawatt for the solar rooftop potential. So if you are seeing this particular graph, so you can find out that India has already given the target around 40 gigawatt for the solar rooftop and 60 gigawatt for the ground mounted system. And this 60 gigawatt, the 20 gigawatt will segregation by the solar park, the 10 gigawatt for the unemployed youth and farmers. So the Kusum Yojana has come in this particular region, and the rest of the 30 gigawatt of the total potential will be installed by the government, state, and the private and others player in upcoming 2022. So these are the things from the power sector. Any question from anyone? Yeah, any question from anyone? Okay, so now we come to the more closer to our designing part. So we require to the basic component, and these are the basic component which is the required to generate the any solar system or solar power. So the first important component is the energy source. The energy source is basically defined by the sun energy, and that the sun energy will be coming to the energy conversion devices. So basically, this is called to the solar module. So this is the energy conversion kind of thing. So this is a solar module. Now, after the whatever the energy will be generated, it will be go to the energy inversion and conditioning unit. So that is called to the inverter. And if we require to the storage of energy, so we can also go for the energy storage kind of thing. So with the help of that, we require to the battery backup or something. So we can also use to the energy storage devices. And after getting to the power, we give to the energy distribution from the energy uses and the electric utilities. So these are the basic components. Apart from that, you will require the mounting structure, you will require the cabling, you will require to the data structures, to all the other component is coming to the upcoming slides. Now, there is a few types of solar power plants. They basically have using to the designing of the solar system. So the first type of solar system is called to the on-grid PV system. So the on-grid PV system is a basically work in a two type. One is the large scale production. This is basically defined by the without battery, and the another system that will be called to the with battery kind of system that will be called to the smart grid concept. The second type of system is called to the off-grid system. So the off-grid system is basically the two type with battery, basically which are the utilized for the industry and the houses. And the another system is the without battery, which is called to the PV water pump and the other system. The third type of system is called to the hybrid PV system. So in a hybrid PV system, that will be the combination of the wind plus PV hybrid system or the PV diesel based hybrid system. So that is the different type of segregation is defined to the solar PV system. The another type of system is we call to the PV based utility, and our solar lamp, solar mobile charger, and the other particle has come to this particular segregation. So now we understanding. So now we understand in upcoming slide what are these type of solar power plant and what are the things or what are the components we will require to designing of such type of solar power plant. So the first solar power plant we discuss about the standalone. The standalone system is also called to the off-grid system, and the sometime this is called to the battery backup system. So in a standalone system, we have using the solar module, solar charger, battery, and inverter. So now if you see this particular graph, so here this is called to the layout of the off-grid system. So we just use to the PV array and directly go to the DC load. So that is called to the direct coupled PV system, and our water pumping system are working on this particular segregation, and this segregation has called to the direct coupled PV system. This is the typical example of the standalone system. So here first we using the PV array, then the energy will be go to the charge controller, then is go to the battery, then is go to the inverter, and finally is go to the AC load condition. And from the charge controller, it is also go to the DC load condition. Now, the second types of system is called to the on-grid system. So in on-grid system, we did not use to the any battery backup, standalone system kind of thing. So whatever the energy we will generate it, we directly feed to the grid. So this is the PV array, then it's go to the inverter or the power conditioning unit, and then after it will be go to the distribution panel, and from the distribution panel, it will be go to the AC loads and electric utility. So such type of system is called to the on-grid system. In on-grid system, we did not require any backup system. Whatever the energy will be produced is directly feed to the grid condition. The third type of system is called to the hybrid system. So in a hybrid system, we have using to the different type of segregation like that. In a single place, we have using to the two different or three different type of technology. So this is a typical example of the hybrid system. So in a similar place, we have using to the solar module, we have using the wind energy, we have using the diesel generator, we have using the battery backup. So that the combination will be called about the hybrid system, and nowadays the hybrid system is the more famous in the different places and the different the surroundings. So that is a call to the hybrid system scenario. Now we come to the next topic. Any question from anyone till now? Any question from anyone? Okay, so now I just go to the one quick case study with you. So suppose that if we go to any PV project phase, or if we go to the designing of any project or something, so what are the basic data is required for the implementation of solar project? Can anybody tell me what are the basic information we just collected from the customer or the factory owner or some people? What are the basic things we will require?
Sir, first we need the load requirement.
Yeah. You are right, sir. Then only if you know the load requirement, so you can design
No,
the solar power plant.
there are other things that availability of area, grid connectivity.
Okay. Anything else? Okay, so you just tell me ki area, load, grid connectivity. Okay, but that is a call to the some the punch point kind of thing. So whenever you develop of any project phase, we require the some steps. So whenever we start to the designing of any solar power plant, we start from the concept side. So the first thing we require the concept. What is the meaning of the concept? The concept is basically told you which type of solar power plant you want to install, either the on-grid, either the off-grid, or the hybrid kind of system. So whenever you develop of any project phase of any area, first you require your concept of the customer or the company or the organization where you have want to install your system. The second step is the pre-feasibility study. Okay, so in a pre-feasibility study, we have checking the area, but this area is not enough. You always require to the shadow-free area. Okay, because if you are putting your module in any shadow location, so it will be the wastage of money. So whenever we install to the solar energy, we always focus that the area will be the shadow-free of that particular location, and with the help of that we can generate to the maximum amount of energy. So that will be also required to the project phase kind of thing. So the pre-feasibility study, we have just cross-checked to the shadow free area of that location. The next step is the feasibility study. So in a feasibility study, we have see that the temperature, humidity, wind speed, then we will also see that the grid connectivity, the transportation, the manpower. So everything we will have done the feasibility study. So whenever we develop a any project phase, so the first step is the concept, the second step is the pre-feasibility study, the third step is the feasibility study. Now, when you complete it with these three steps, the next step is the design and development, and that is the important the aspect. And the today's our topic will also focusing on this particular thing, the designing and development of the system. So you can design your system in a two method. Either you can design your system in the manual method, or either you can design your system in the simulation software basis. Okay, so whenever you design your system in the manual method, so like that, if your plant is a 1 kilowatt, 10 kilowatt, 50 kilowatt, or 100 kilowatt, sometime in 100 kilowatt, so you can design in the manual calculation. You just do the Excel sheet and then you can design. But if your plant is beyond the 100 kilowatt, like the 200, 500, 1 megawatt, 10 megawatt, 50 megawatt, 100 megawatt, so you cannot design in a manual basis, because the designing of the large scale solar power plant, there's a lot of the permutation and combination is required, and with the help of that we have requiring to the different type of simulation software. So in upcoming the slide we will discuss to the types of simulation software, what are the types of simulation software available in the market, and how they will be segregated in the other competitor, what is the who will be developed this thing, and what exactly they are doing there. So you can design and development of the solar system, and your final step is the construction and the commission. So that is the five phase will be required to the developing of any project phase in any area. So we just go to the concept, then we go to the pre-feasibility study, then we go to the feasibility study, then we go to the design and development, and finally we go to the construction and commission area. Now we come to the next topic, and that is very interesting, because when we assessment of the data, or whenever we assessment to the solar power plant, we require to the energy yield assessment. So understanding the energy yield, we just go to the quick exercise. So please be ready with the your pen and copy. I just give a one question to you. Suppose you have the 1 kilowatt of system, okay, and this 1 kilowatt of system is per day is working in a 5 hours, okay. Just listen the question very carefully. You have a 1 kilowatt of system, and this 1 kilowatt of system are working to the 5 hours. So now tell me, in a one day, how much energy it will be required?
Sir, how much unit is generated?
Yes, how much energy or how much unit? Yes.
Sir, around 25.
How?
Sir, actually 1 kilowatt roughly produce 5 units.
5 units. On which basis?
Pardon?
On which basis?
Sir, actually in the literature I have studied about that 1 kilowatt solar plant roughly generate 4 to 5 units in a day.
Okay. So my question, just listen my question is very carefully. You have a 1 kilowatt of system, okay? And that system are working in a 5 hour in a day. So how much energy it will be generated in a one day?
It is 5 unit only.
5 units, okay. Absolutely. Now, the same system are working to the 30 days. So how much energy it will be generated?
200.
50.
So yeah, तुक्का नहीं मारना है, just calculate कीजिए.
30 days.
Yeah, 30 days.
150 units.
150 units, okay. Now the similar thing, if we go to the 300 days, so how much energy it will be generated?
4,500 units.
Absolutely wrong, sir.
1500.
1500, yes. 1500, because if the system has working in a one day in a 5 unit, 30 days of 150 units, so the same system are working to the 300 day, it will be generated around 1500 unit. If your answer has coming to this thing, so you are calculating the right answer. Why I'm giving to this exercise to you, there is a two different things here. Now the first thing, why I'm using to the 300 day, because in a year there is a 365 day, but I did not consider to the 365 day. I'm only consider to the 300 days here. Can anybody tell me why I'm considering this thing?
Sir, you have excluded the
300 days.
rainy days and cloudy days.
Yes, so I just take the 60 day, the cloudy or rainy day. So in the cloudy and rainy day, my solar system is not working. Okay. Now, so that's why I just taking the 300 days on the place of 365 days. Now you can calculate this energy, the 1500 unit, and this 1500 unit is the energy yield of the system. So what is the formula of energy yield? That is the formula of energy yield is kilowatt hour upon kilowatt peak, means how much energy you can generate it and how much the plant you have installed on that particular area. So if you are getting to the 1 kilowatt of system is a 1500 unit, the similarly if you go to the 1 megawatt, 2 megawatt, you can just calculate it this thing. So the energy yield will be defined by the kilowatt hour upon kilowatt peak. So the formula is, so that if you install to the 1 kilowatt of system, how much energy we will find out that particular location. Now, the one more interesting thing is there, because in India, the sunshine hour will be vary from 4 to 7 hours. So sometimes some places your the radiation is your radiation available for the 4 hours. Some places is the 7 hours, and some places in the 5 or 6 hours. But if you do in an average of everything, so you can get to the 5 hours of the day. So that's why I will take the 5 hours. But this energy generation will be different from the location to location. This is not the universal thumb rule. If you install to this much plant, so you can get this much of energy. It will be vary from the condition to condition and the location and location. So now we are understanding what is the meaning of energy yield. So the energy yield will be denoted by the kilowatt hour upon kilowatt peak. Now, how the system will be affected to the energy. So there is a different types of the parameters which will be affected to the energy yield. The first parameter is the module, the system component, like that module and inverter. If you are not using to the certified module, certified inverter, so that particular case, your energy yield or your the PV performance will be affected on the system. So always you are trying to do, if you are putting the solar power plant in any location, you always try to do that your module or inverter will be the certified by the IC certification, and it will be certified by the BIS certification also. So if that type of things is there, so it will be generated to the maximum amount of the yield energy. The second types of parameter, that is called to the irradiation behavior. So the irradiation behavior, we already discussed with you, if the radiation will be lower, so your system will be not generated to the optimum amount of energy. So it will be affected to the total overall the energy generation. The next step is the climatic zone. Anyone have any idea how many types of climatic zone in India? Anyone has any knowledge how many types of climatic zones in India? Mr. Deepak, you asked me one question, how to assess the peak time availability. So this peak time availability, you can find out the meteorological data, and from there you can find out how many hours your sun is available on that particular location. So with the help of that, you can find out the data from that particular location. Okay, so now we discuss about the climatic zones. So in India has the 5 different climatic zones, like that the hot and humid, hot and dry, temperate, cold, and the cold region. So that is and the composite region. The fifth region is the composite region. So when we're talking about the hot and dry condition like the Rajasthan and Gujarat, hot and humid condition like the Tamil Nadu, Chennai, and the Kerala, that is called to the hot and humid condition. Then the temperate condition, those the places where the no summer, no winter, so such kind of condition will be happening in a Bangalore. So in a Bangalore will we come to the temperate region. Then we have the cold region like the Leh Ladakh, Northeast, Uttarakhand, and another places will become to the cold region. And the remaining of the region will become to the composite climatic condition. So in every places, my module have working in a different way. So that's why the selection of module is a very, very important from the climatic condition wise, because if you are not putting the proper module in the proper location, so you cannot getting the optimum amount of energy yield from that particular power plant. Then the next effect is the temperature behavior. If your system has installed in a very hot condition, the very high temperature is there, so your system is never ever go to the optimum amount of energy yield condition. The next is the effect is the spectrum effect. So the every module has covering to the spectrum variation, because the module has working to the 3 different region like the ultraviolet, visible, and the IR region. So the ultraviolet region is the more danger for the module, because if the ultraviolet region is coming for your module, so your module will be damaged and it will be not generating to the optimum amount of energy. So now the day, what the people has do, the people has doing, they are making a module in a visible region and the IR region. So that's why they will collecting to the maximum amount of the spectrum energy. And if they are getting to the maximum amount of spectrum energy, so it will be utilize the maximum amount of energy on that location. The another important part is the incline and alignment. So incline and alignment is also the very important the parameter, like that if you did not put up your module in the right angle and the right alignment, like that if you are not putting your module in the right tilt angle, and if you are not putting your module in a proper the angle, so it will be not generating to the optimum amount of energy, and you lose your energy ill on that particular condition. The next effect is the shading effect. In a shading effect, we can see that if any shades or some portion will become there, so definitely it will be damaging your module, and your module is not generated to the optimum amount of energy. The next is the swelling of the module. The swelling of the module is also affected to the system generation, like that if the dust accumulation is happening on your module, so you cannot tracing to the proper power of the module, and it will be not generated to the optimum amount of energy. So these all are the parameters which are the affected to the energy yield. And if we are minimize this parameter, so we can generate that particular location. So these are the important factors for the deciding to the system on the location, and with the help of that, we can generate it to the maximum amount of the performance on the different to different location. Now we come to the source of radiation data. So sir, your answer is here. So we have getting to the our resource data from the different platform. So there is some platform is a free of cost, or some is a chargeable. So you can getting the peak energy demand from the metronome, from the WRDC, that is called to the World Radiation Data Center. Then you can find out the data from the Ratiscreen software. Then you can find out your data from the IMD, that is called to the Indian Meteorological Department. Then you can get your data from the NASA site. Then you can get your data from the 3-tier website. Then you can get the SRRA. So in this particular thing, like that IMD, NASA is the free of cost, and the rest of the things you can pay the money, and after that you can get the data. The last one is the SRRA, that is called to the Solar Radiation Resource Assessment. And this resource assessment, the data from the India side, so whatever the plant the India has installing, they will follow to the SRRA data. And if you want to this particular data, so you can purchase this data from the National Institute of Wind Energy, and they will be providing you this data in a very less amount. The IMD data is free, sir. If you go to the Anna Malai book and other things, so you can find out the free of cost. So you just follow to the Anna Malai book. She is the scientist from the IMD, and she already published a lot of meteorological data on her book. So you can just go there, and then you can take the data from there. Now we come to the next topic. Any question till now? Any question from any part?
How can we obtain the IMD data freely?
Yeah, you just go to the website, and then you can cross check. Or if you did not getting the data, you just go to the Anna Malai the book. This ebook is already available in the Google. You just download, and then you can select the data. Because this metronome data, what is the importance of the selection of data? Because the data is always defined by the TMY basis. That is called to the typical mean year. Like the typical mean year means you can save the data from the 20 to 25 years data, and with the help of that, you can taking the one single point is there. If you are putting your solar power plant in a 2020 data, you never ever get to the optimum amount of energy generation. So whenever
Actually,
you design to the yeah, pardon?
sir, suppose I want the radiation data for my city.
Yes.
So is it available over there? How?
Yeah, if you go to the metronome site, so it will be available. So at the end of the session, I will show you if you want to your data from your city. So it is also come in the software. So we have some software. I will explain in upcoming slide after 2 to 3 slides. So we will go to the software section, and then I will explain you how can get you the metronome data. If you have a software, you can access the data. But if you do not have the software, so you can just go to the NASA website or the IMD website kind of thing. So you can find out the data from there.
Okay, sir.
Yeah. So now we come to the next topic. That is the silent future of the SPV power plant. That is called to the DPR. That is means the detailed project report. So whenever we design to the any solar power plant or when we have executing of the any solar power plant, we require a one DPR. In a DPR, all the detail is given in the system like that module, inverter, system, cable, everything is there. So we just executed this thing from that particular location. Now in this particular things, uh, 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 the things we just decide by the location. We just talk about the state, then we go to the locality, then we go to the name of building, then we go to the latitude, then we go to the longitude. So it will be the different type of the things like that. We just define the location. We just talk about so the locality, the name building, the latitude, longitude, and other location. The another parameter is the area of SPV power plant. So here we have taken the length, width, and the location. So then after we will go to the technical detail of the SPV module, like the PV module types, the physical dimension, length with frame, width with frame, the thickness, electrical parameter, the maximum power rating, the rated current, the rated voltage, short circuit current, open circuit voltage. Then we will also decide the SPV power plant, like the output, number of module in a series, number of module in parallel, DC bus. Then we go to the mounting arrangement, like that how many types of mounting is required, like the single axis or the dual axis, the fixed tilt. So this is also decided in this TPR. Then we will go to the inverter and power conditioning unit. So how many numbers of inverter will be required? What are the capacity of the inverter? Then we have the input voltage range, then the output voltage range, then the frequency, then the efficiency. Then we go to the grid connection detail, like the electrical parameter and the interconnection. Then we go to the annual energy generation, means how much annual energy generation so is required there. Then we go to the cost estimation, the estimated cost in the lakh and other things. And then we go to the cost of energy generation, like that the levelized tariff in the rate per kilowatt hour and the cost of generation. And then the next is the real-time data logging that will be using for the event logging, the supervisory control, and the operational mode. So these are the data will be required from the system. So that will be the thing in the system. So now we come to the next thing. So with the help of that, we can providing this thing. So that will be called to the silent future of the SPV power plant, and that is called to the DPR of the system. So the DPR means all the gist information is given there on the particular thing. So that will be denoted by the plant estimation. Now we come to the plant cost conditions. So in a plant cost, we just define to the site preparation cost. So we will require to the levelizing of the sites. Then we will require the shipping and material cost. Then we will require to the shipping and material cost. Then we will require the labor cost. Then we will require the water cost. Then we will require to the fuel cost, and then we will require to the connection and the cable loss. So that will be the different type of the things we will be required for the plant cost estimation, and that is the useful for the system. So the major costs will become like the site preparation, the shipping and material cost, the labor cost, the water cost, and the fuel cost, and the connection and the cable cost. So these all are the come in the plant cost estimation. Now we come to the capital cost of the. Yeah, someone asked some question.
नहीं यादव नाम है यादव.
Yeah, Kametum, you want to
हम
say
अकाउंट नंबर बोलते हैं, अकाउंट नंबर चेक कर लीजिएगा, मालूम पड़ जाएगा. हाँ दे तो.
Yeah, I'm requesting the participant please mute yourself.
हम करते हैं. हो गया ना. Six.
Yeah, please mute yourself, sir. Okay. So now we just talking about the capital cost of the solar photovoltaic of the power plant and how can we do the cost estimation is here. So this is the roughly figure for the 1 megawatt of system. So if you install to the 1 megawatt of system, so the total cost will be required around the 4.15 crore in the CERC, the regulatory. But nowadays, the 1 megawatt plant will become around 3.5 to 3.8 CR. And the major cost will be here is like the PV module is the PV module cost. So it will become around the 59.31% is there. Then we have required the land cost, so it will become around the 12.03%. Then we go to the civil and journal work, so it will become around the 5.51%. Then we go to the mounting structures, so it will become around 5.51. Then the power conditioning unit, it is also come around 5.51. Then we go to the evacuation, the cost of the interconnection point, like the inverter connection and other things. So we will just require the cabling and other things. So we will require around 6.92%. And then we go to the pre-operative expenses and the preliminary operative expenses like the transportation and other things. So we will just taking care of this thing, and with the help of that particular costing, we will install to the solar power plant in any area. Now we just come to the capital cost of the thing. So the another very important costing is the cleaning of the module. So can anybody tell me, anyone have any idea if you're cleaning the module, how much water will be spending here? So if I just give a one small idea about to you in the 1 megawatt of solar power plant. So if you are going to the cleaning to the module with the help of the surface water, so in yearly, you can invest around 91,875 rupees per megawatt of per year if you are using to the surface water. And if you are using to the groundwater, so you can use around 54,075 rupees for the per megawatt of the per year of the system. And this cost will be observed the higher as the dry state like the Rajasthan and Gujarat. But yes, the solar potential is very good is there, but the water availability is very less is there. And if you're talking about the water requirement of India, so around the 7,000 to the 20,000 liters per liter water will be required for the per megawatt of the per wall. So if suppose that in a 15 day, if you clean your solar module, so you just required around 7,000 to 20,000 of liter of per megawatt of per watt, and it is basically the panel will be the clean in a weekly basis, and it will be vary in the scale and the location of the plant. So that will be defined by the groundwater and the surface water condition. Now we come to the operation and maintenance part of things. So I just give a quickly things to you, and then we come to the our designing part. So we just go to the module cleaning is a requirement for the operation and maintenance. Then we will also cross checking the module connection and integrity. Then we will also see that the junction box and the string combiner box. Then we will also do the thermographic detection for any faults and other things. Then inverter servicing is also required. The inspection of the mechanical integrity and the mounting structure is also very much required in the operation and maintenance. Vegetation control is also required to the system. So these are the things will be required in there. But now we come to the our main topic, that is the PV system sizing tools and the simulation. So I already told you why we use the simulation software, because in a simulation software, in a very less time, you will efficiently we design of any solar power plant, and we can find out the maximum amount of energy generation. So now a wide variety of the software tools is exist for the analysis, simulation, and the sizing of the photovoltaic system. And this tools is present to the different degree of the complexity and the accuracy depending on the specific task for which each tool has been developed. And it is a usual to the distinguish between the sizing tools, which is the determine the component size and the possibly the configuration, and the simulation modeling tools, which analyzes the system output, the performance of the specific node. And the most important thing, with the help of simulation software, we just minimize our timing, and with the less amount of the time, we can efficiently design to the maximum amount of system. So this is the sizing tool, that is the max design that will be developed by the max design, and that will be sourced for the solar max people. And this max design is the basically offer to the different type of design variation, the different type of configuration, and that will be the important from the energy yield calculation, the analysis of the DC line losses, and the another things. The next software is the Ansel software. So it will be included the module for the standalone PV system, the PV generator hybrid system, and the grid tied PV system. Then we have required the PVGIS software, and this is a wave application based of the software, and it will be estimated the power performance system in the located in Europe. But now this day PVIGS system is also working in other location also. This three software is the chargeable, so it is not in the free of cost. Now this three software is the free of cost. You can just download on your system, and then you can design the system whatever you want to design. The first software is the PV Watt, that is developed by the NREL, and this software is the internet accessible tool, which is basically calculate the energy yield, energy production, and the grid connected of the PV system. Especially they are making for the United States and other territory, but it is also working in the Indian condition also. The another software is the RAT screen, and that will be developed by the Canada, the Canment Energy Research Laboratory. And this particular software is the Microsoft Excel based software. So when you design the system, all the Microsoft Excel file will become there, and with the help of that, you can design your system, and it will be given to the efficient type of calculation, because with the help of the RAT screen, you can design the renewable energy technology model, you can design the hybrid PV system, you can develop the Microsoft of Excel spreadsheet and the workbook file, and etc. The another software is the SAM software, that is called to the System Advisor model, and is also developed by the NREL. So SAM makes to the performance prediction for the grid connected solar, the small wind system, and the geothermal power system, and it is also useful for the economic estimation for the different purpose. So the SAM software is also available in the market, and this is a free of cost. But now in industry, apart from that, the another software like the Soul Matrix PV Designer, so it will be also given the result like the partial shading and other things. Now the Homer is a very the prominent software, and if you design to the hybrid optimization model like the electrical system, so this Homer software is the very nice software for the standalone, the electric grid, and the hybrid power system or designing. Then we have come to the Transys software. So this tools will be basically using for the solar thermal application. So if you design to the any system with the help of a solar thermal power plant or solar heating system, so you can just go to the Transys software. Now this is the two important software which is basically used to the industrial revolution. So if you're talking about the solar industry, so these two software are the prominent way, are working in a very fast way. So the first software is called to the PVC software, and this will the people from the software will developed by the German people, and the PVC software is basically the PVC software package. Basically, it will be used for the sizing, designing, data analysis of the complete system, and it is very suitable for the grid connected, standalone, and the DC grid type of system, and it is offered to the extensive meteorological data. So the one person has asked to me if you require the meteorological data. So with the help of that PVC software, we can generate the meteorological data, and then it will be utilized from your location. Then we have the PV Sol expert. So the PVSys and the PV Sol is the most prominent software which is useful in the industry, and a lot of places we have using to this software, and this software will be give to the lot of report the people are making to this the same software. And what is the difference between the PV Sol and PVSys? So only the one major difference in the 3D visualization. So if you go to the PV Sol software, so there is a very good 3D visualization of the manufacturing and the weather database. So you can also determine the electrical consumption, the throughout possibility and other things. So in the PV Sol software, that is basically using for the designing, planning, simulation of the PV system. Then it will be required the program features that is including to the grid connected, standalone, and the another numbers of the different types of angles. So that will be the 3D visualization is a very, very good in the PV Sol software. But if you're talking about the technical perspective or technical point of view, so the PVSys software are the majorly used in the industry. I quickly show you the methodological data, how can we incorporate it to you. But before coming to this part, we just go to the summary. So now is this last 2 hour session, what are the things we learn here? So what are the topics we cover here? So the first we cover to the basic solar photovoltaic components. So now tell me what are the basic components are required for designing of solar power plant. So this is a question answer session. So we just summarize this thing, and then I will go to the PV system, the real way how can you design the things in the PV system. Yeah. What are the basic solar photovoltaic components?
So these are modules, mounting structure, power conditioning unit, batteries, inverters, meters, etc.
Okay, thank you. How many types of SPV power plants?
Pardon? There are 3 types mainly.
SPV power plants.
Yes, sir. Solar photovoltaic plant basically 3 types. One is off grid, and grid connected, and hybrid.
Okay, what is the hybrid?
Hybrid means solar plus wind and solar plus DG, etc.
Okay, and what is the off grid?
Off grid means it is not connected to the grid.
Okay, okay. Now the energy yield assessment. What is the formula of energy yield? How can you determine the energy yield?
Sir, it is kilowatt hour divided by kilowatt peak.
Okay, so if you install to the 1 megawatt of solar power plant, how much energy it will be generated?
1 megawatt.
Yeah.
Sir, it is 1500 into 10 to the power 3.
Yeah, so it will become around 15 lakh units. Absolutely.
Yes, sir.
We are getting the point. Great. Now, what is the project phase? Developing of project phase. What are the steps is required for developing a project phase?
So there are a lot of phases,
Yeah, such as we discussed the
pre-feasibility study,
Yes, yes.
feasibility
We start from
study,
the
resource
concept.
assessment.
Yes. We go to the concept, then we go to the pre-feasibility study, then we go to the feasibility study, then we go to the design and development, then we go to the construction. Okay, there are different parameters on the PV performance. What are the parameters affected to the energy yield?
So there are a lot of parameters like behavior of solar radiation, behavior of temperature, latitude, and location, clouds, temperature,
Soil
etc.
spectrum. Okay. The DPR. What is the meaning of DPR?
Sir, it is the detailed project report.
Okay, so what are the things are coming in a DPR?
Sir, all the things like the different cost and different components, etc., and economics, etc.
Okay, okay, okay. Now the plant cost estimation. What is the plant cost estimation? Plant cost estimation. So we have required the labor cost, the site preparation cost, the fuel cost, the transportation cost. So all are the things will be coming in there. Now the PV system designing and tools and simulation. What are the softwares is required for designing of the system? What are the major softwares required for designing the system? I will explain you the lot of name of the software. What are the major software you are using in the designing? Yeah, we have the PV Sys, PV Sol, Ratiscreen, Homer, PV Watt, the Alloscope, Oscilloscope. So that's all are the software there. Okay, so this is the some achievement from my couple of years. So you can see from this slide. And I'm also give the training in the international platform and other things. And that is the some award I getting in the last couple of years. So thank you very much for your kind attention. I quickly go to the that particular point. I just explain you how can you do the meteorological data with the help of the PVC. Yes, my
नौकरी
screen
करते हैं बगा दी.
for you. Just can you see my screen? So that is the software that is called the PVSys, and if you require to the meteorological data of your location, so there is some future is there. How can generate the meteorological data of your system? So now tell me, sir, what is the location name? So I will just explain you how
So it is
can you get the
Jodhpur,
meteorological
Rajasthan.
data. राजस्थान तो ऑलरेडी होगा उसमें.
Jodhpur.
Okay. So I just there's some map will be open there, and if you require to the Jodhpur data, you just type in a
It
Jodhpur.
is J or D.
Okay, sorry. Now,
Yes, sir.
so after you just give the name and just click in the search button. So if there is some location, so definitely it will be go there. So we just see that the location is there or not. Now in the right hand side, it will be come here, but my map will be not moving from here and there. Just one more minute. I just want to show you the other things. Sometimes it will be depend to the internet connectivity also. But now in the right hand side, you can find that this is the Jodhpur, India, latitude, longitude, altitude is all these things there. Now you just go to the accept of the data, and from there you can find out to the different type of data like the meteorological data, NASA data, PVGIS data, the NREL data, and the soil cost PMY data. But generally we have using to the metronom data. So we just go to the metronom data, and we just import this
Sir, which
particular
software you are
data.
using?
That is the PVSys.
Okay. So it is freely available?
No, it's not freely available. It is available for the 30 days, but after that you can pay the price for that software actually.
Okay.
So this is the data you can find out here. So they will be give to the global horizontal irradiation data, then they will give to the temperature data, then they will give to the wind speed, then give to the link turbidity, then the relative humidity. And if you did not require the data, so with the help of that software, you just illuminated the things, so it will be illuminated there. But if you require the data, so you just go there and then you just click the save button. And after the saving the things, you can find out your data on the meteorological the system, and then you can design your system in a very
So
efficient way. So
these are for which particular time period?
no, this is the time period from the 1996 to 2015.
Not the recent data.
Here? Pardon?
Recent data is not available?
Sir, I already told you now, when we design to the solar power plant, we always go to the TMY data. If you
Okay,
design your system in only the 1 year data, so you did not find out any output is there actually. Okay, so the designing of the system we have using to the bigger data like that. If we go to the 10-year data or 25 years data, so we can get the maximum amount of the maximum amount of accuracy is there actually. But if you did not if you want to install your, if you want to design your system in only the 1 year data, so you did not get the accuracy is there actually. If you want to design the system in a 2020 data, so I think in this particular year, the 2020 data is not similar this year. So it will be different from the year to year basis. So that's why we have just using to the different types of the data. We just use to the TMY data, that is called to the typical mean year data, and this particular data is really useful for the designing of the system. This is from my side. Any person has any question or anything, so you can ask to me.
Thank you very much, sir, your talk, sir. I think so. There are no questions for the participants. You have, during your talk, you have answered all the queries. So thank you very much for your talk. Now, I would like to request inform the participants that the next session will start tomorrow at 10 a.m. And so we thank you for your cooperation and be there tomorrow. And tomorrow there will be the feedback form will be sent by mail, and tomorrow there will be an assessment test which will be sent through Google Form. Thank you very much for joining us, patient with us, and hope for your cooperation tomorrow. Thank you very much.
Yogesh sir, please share your email ID, sir.